Okay, here's another example of how to use this compound interest concept, which is I have here the formula for this compound interest, and let's say what's the setting here is math saving for a new car. Actually, the same math from the previous example, I believe. And he invests 5,000 into an account that pays 3% interest a year. So far, it looks pretty much the same case as before, and is compound monthly. But here comes the thing. The question is, how long will it take his investment to double? So last time we were requested to find a final value, and now we are requested to find a period of time, an amount of time, which is we are requested to find the time. So first, let's see what we got here directly. So the initial value just remains the same, which is this 5,000. So let's say I have here the P, it's equal to 5,000. Now the interest rate is actually the same one, which is R, it's equal to 3%. Again, we can't just write 3%, we have to transform it to decimals. It will be 0.03. The n, which is the number of times compounded, will be just the same as this compound monthly. It would be a year divided by 12 months, so it's n it's equal to 12. Now the time, we do not know the time. This is what we are requested to find. Now the thing is, we are requested to find a time when his best investment will be doubled. In this case, now that is to say, we have to find the time when the final value a will be double the time, will double the initial value. In this case, a will have to be equal to 10,000. There it is. Now, with this in mind, we can just use our nice formula we have here. So let's see, instead of a, we'll have 10,000, which is equal to p, which is in this case 5,000. There it is. Times will be 1 plus r over n. R is again 0.03 over n, which is 12. There it is. Yep. Will be all raised to n times t. Will be 12 times t. There it is. Now we got all these values, and the only one that is we do not know is this value t, which is on the exponent. Luckily, we just found ways to solve this kind of equations when the variable that we do not know it's on the exponent. So let's see how can we solve this out. First, I'm going to simplify out. So will be I'm going to divide both sides of the equation by 5,000. Maybe here 5,000. All over here will be 5,000. And as you can see, we can simplify out here on the right. I'm simplifying out these two. This 10,000 and 5,000 will be equal to 2. 2 is equal to, now this number that we have in these parentheses, we already solved it in the previous example. We know that 1 plus 0.02 over 12 would be equal to 1.0025. Be raised to the 12 times t. Now, if you don't remember this, you can verify this result in your calculator. So let's see. From here, I'm going to solve out using logarithms to get to handle this t, which is an exponent. Now, I can use actually any logarithm, but I could. I'm going to use the log base 10, which I believe everybody has in its calculator. So I'm going to use the log base 10, apply the log base 10 of 2 on the left side, and now I'm going to apply the log base 10 on the right side as well. So it would be looking like this: 1.0025 raised to the 12 times t. Now, if you have a super nice calculator, you could just use a log base 2 or even the log base of 1.0025, which will make your life much easier. If you don't, just don't worry. You can just use these logs, log base 10, and it would just work nicely with the same result at the end. So this would be, now we know with using these logarithmic properties, we can just move what's in the exponent goes down multiplying to the base to this log. So this will look on the right like this: 12 times t times the log of 1.0025, and on the left we'll be having a log base 10 of 2. Now we got this numerical value and this numerical value, and as well this one. So we just only have this t as something within the unknown variable, so we can just solve this out. I'm going to divide here both sides of the equation. Divide both sides of the equation by 12 times the log base 10 on 1.0025, just to cancel out this what's here, not the t, what's not the t. So it will be on the other side, it will be 12 times the log of 1.0025. It's a bit messy here, sorry about that. So we can solve this out using a calculator. On the right side, you can cancel out this 12 with this one, cancel out this log with this one, and you will only have here remaining the t. So in other words, t will be equal to, we have here a log base 2, and dividing this log base 2 will be 12 times the log of 1.0025. Now this may look weird, but you can solve this out quite easily in your calculator. You just have to input these values, and actually I already have done this. Solving out this expression will get us in return a amount of time will be 23 times 13 years. And this is actually what this result is meaning. It's that this one, this 23.13 years, it's actually how long will it take for this investment of math will be actually doubling, get to this 10,000. We're starting from 5,000 to 10,000. You with a 3% interest in a year, you have to wait 23.13 years in order to get to double your investment. So actually that will be all with this video.